should be subtitled Big Boys Toys, shouldn't it? That is GHY6. Goonhilly dish number 6. And that's what we're going to talk about. So, little bit, there's a lot of folklore about Goonhilly at the moment because people aren't sure quite what's going on. So I thought a little bit of history, a bit more recent history. How did we get to play with big boys' toys? What did we do? And what's the future? So everybody remembers Goonhilly because of what was the BT era. The number of people who you meet who say, I took the family round, or my dad took me round, or I remember going to the visitor centre. It started, it was the original UK satellite Earth station. In 1962, the 26-metre dish called Arthur received the Telstar transmissions. And there's a bit of story behind that, of course. On the first orbit, the French dish in Rennes received it and Goonhilly didn't. And they got the polarisation the wrong way round at Goonhilly. So on the second orbit they did get it. Or they got a P1 on the first orbit. On the second orbit they got a P5.
One suspects it was the Americans having built those of the other stations.
See, folklore, I told you. Anyway, by 2004 there were 64 antennas, making it the largest teleport in the world. But by 2006 BT had a rethink and decided that the world was going to go fibre, that satellites were no more, it wasn't their business. So they actually began to scale down activities at Goonhilly, and they've moved all of their satellite operations to Madley in Herefordshire, where interestingly there are 2 more of the 32-metre dishes that we played with. The visitor centre continued until 2010. The site was generally mothballed. The visitor centre closed in 2010 quite suddenly. They announced just before Easter that was it was going to close, having had 80,000 visitors in 2009. So it was a really, really popular tourist attraction. The site was mothballed and eventually sold to their current owners on a 999-year lease in 2014. BT are still there. There is still an important site for BT, but very small, basically one building. It's where they land a lot of the submarine cables. So actually it's one of the most connected places in the world as far as internet goes. But the rest of the site has been bought by Goonhilly Earth Station, or GES as we know them, and that's a group of satellite engineers who are enthusiastic about the site, backed by investors who put money into it as a satellite Earth station. They're gradually building the site back up. I mean, Dave and I have been there. I mean, it's criminal the way it was just left. They just left it to ruin, really. But they've managed to get all of the dishes except the big 3 back in traffic. They have built some new dishes. They've got that much traffic. They bought all of the dishes when the BBC closed the television centre. They bought all of those dishes and taken them down to Goonhilly. And they're actually on Twitter, when we were down there last time, they've just built a new 16-metre dish. Interestingly, and I'll probably cover this in a minute, 2 of the dishes are listed buildings. So GHY1 and GHY3 are listed buildings, and that was because in 2004 a group of BT engineers saw what was happening, and we understand got them listed to preserve them as such, because there was a rumour going around at the time that they were going to flatten the site and build a wind farm. Young enthusiastic group, about 20 people running it. They're very keen on developing STEM. They're very keen on getting the science message out there. Cornwall industry. They're keen to support what we're doing because they see it as an important part of technology. And there is a desire to reopen the visitor centre, but their investors are saying, this is not our core business. You know, you focus on making money from satellite uplink and traffic. So Graham, it's Graham's fault, our dear president, met Ian Jones, who is the CEO, at a space conference, and being Graham, those of you who know Graham, he's a little bit up front, a bit like me. He basically said, can we put a FunCube ground station in at Goonhilly? And Ian was keen to support, and he said yes. So there is a FunCube data ground centre down at Goonhilly. And then we went on and asked, when we started to do the Tim Peake stuff, we had the cheek to say, don't suppose you've got a dish that can track the ISS? And sure enough, there is a dish at Goonhilly, but to be clear, it's not actually owned by Goonhilly, it's owned by Satellite Catapult, who rent the space off Goonhilly. But anyway, that's the dish we use. That's the dish that Brian is replicating with DigiTwist. That's a picture by Frank, copyright, of the dish. And you all know how successful that was. I mean, that was incredibly successful, the pictures we received off that thing. But during that time, obviously, there's been quite a lot of interaction between us. And so I got to know Matt Cosby, who's the chief scientist who actually lives in Farnborough. Got to know him quite well. And so I inquired about, you know, these big dishes, you know, they look like fun. What do you think? So anyway, there are 3 large dishes. And they were all built when satellites were deaf. They were built, 1 was built in the 60s, 3 was built in the 70s, and 6 was built in the 80s. And at that time, to telecommand a satellite or to do uplinks to satellites, you really needed quite a lot of ERP, as you'll see in a minute. But now satellites aren't that deaf anymore, and your maximum you really need for satellite communication is 13, maybe 16 meters. A 26 meter, 26, 29, 32 meter dishes. I mean, look at the scale. There's people standing in front of it. It is just enormous when you go down there. They're no longer needed. As I say, number 1 was the original Telstar dish, which is very, very close to the visitor centre. And if you ever went to the visitor centre, that's the one you would have driven round, and actually you could walk inside around the tractor feed. You could see the way it moved. GHY3 is also grade 2 listed, slightly different design, you can see. It's not in use. That needs some significant investment. Number 1 has recently moved. They've got it moving again. The motors are running. The whole thing is back up and starting to, you know, get back into service. And number 6 is fully operational, but Smiley Face has currently been decommissioned because they've taken it out of the telecoms traffic and they're about to rebuild it for deep space networks, which is where they see the real future for the big dishes. So it will be doing things like Mars Explorer and the lunar missions, where you need the big dishes for obvious reasons. And they are rebuilding it, or about to rebuild it, hopefully by the end of the year. But there was this window in time where it wasn't doing anything. It's bloody massive. I mean, that is a boy's toy if ever you saw one. It's 410 tons. It was originally designed for receive on 3.6 to 4.2. Note, not 3.1. 5.8, 10.7, and 14 gigs. 14 gigs transmit. I'll show you a picture on that in a minute. Oh. It's a Cassegrain feed here with a tunnel feed behind it. Now that hole in the back of the dish, you can drive an old style Mini through it. That's how big that hole in that dish is. And what that's all about is this tube here. And this tube here is a tunnel waveguide feed, or a tunnel feed. And everything comes off the Cassegrain down through the tunnel, down these mirrors into this central column which is inside the main building. And in here there are some frequency specific feeds which present ports, waveguide ports at these frequencies. So what Goonhilly are going to be doing actually is redoing some of these feeds to present. They're going to refurbish all of this, and they're putting in a new series of feeds. And there was even talk of putting in a 430 meg feed. Anyway, the nice thing is that it presents all of the feeds in the control room. There's 3.4, 5.7 waveguide. You may have seen a post I put out on the reflectors saying, has anybody got a 3.4 gig waveguide transition I could borrow? Wasn't prepared to say why, but, and somebody did actually ask on the reflector and I didn't reply. But Gary provided one, but actually in the end we didn't need it. Goonhilly had got a lot. So the beam waveguide, it literally is a series of mirrors, smoke and mirrors, and it's big enough so it doesn't mode, so it will take its lower frequency cutoff. It's so enormous, but it is a series of mirrors, and then you just put in feeds into the tunnel to pull off the frequencies you want. Now, we've not really got too much of an idea of how clean the mirrors were or whatever, but it certainly worked pretty well for what we wanted to do. How do you move such a thing? So this is the railway track on the second, on the top of the building. There's 4 of these motors which drive it round. That's the elevation control there. And this is the actual physical, well, that's the actual electronics, the original. And they can position it to within 1/100th of a degree. But it was a positioning system rather than a tracking system, if you get the difference. It was designed to work with geostationary satellites. So you put it there and it pretty much stays there. It wasn't designed really to do too much tracking, although we did track the moon with it. Oh. Read that. So 3 kilowatt, 14 gig PAs, and there was 2, and there was a standby pair as well. And don't forget, this is a 32-metre dish.
And you know why they're 3 kilowatt?
Go on.
Because there's a lot of waveguide loss to the antenna.
Yeah, yeah,
That's it.
yeah. So, yeah, and that is one of the twits that comes out of it. And we found an email dated 2003, which was from the BT stores person booking them out. 2 twits at a total cost of £40,800. So, I mean, this is the scale of this is something outside anything we normally deal with. This is real big boys' toys.
Which twit ordered that then? Not guilty.
Yeah, he ordered 4. They only wanted 2.
He's selling on front.
Only needed one.
The path loss for a return path from the moon is 280 dB, plus or minus a bit. Normal EME is done in CW or JT65. You're supposed to sniff when people say JT65 in moonbound circles. Generally, SSB in a 2.5 kilohertz bandwidth is not considered practical. So we went along and went, we'd like to do television. So 250 kilosymbols DVB would be 100 times weaker than that, and 2 megahertz OFDM would be a 1,000 times weaker than that. But yeah, signal strength was a problem, but the major problem actually was the phase distortion. The moon is not what they call a coherent reflector. It's pitted in its own right, but it also curves away from you, and you get effects such as what they call libration fading. Dave, we took every possible mode we could think of. We took AM, we took FM, we took narrowband DVB-T, we took DVB-S, and we tried the FM. Can you explain?
So this is SDR Sharp, and I set up, actually it was a Portsdown transmitter that I modified to give a 1 second pulse and then sit silent for 3 seconds. Round trip time is about 2.5 seconds. So we had time to see our echo come back and then another one. This just kept on pulsing, so we didn't have to do any manual intervention while we were messing around. So on the the SDR Sharp display, the waterfall here, that's the transmitted pulse, and this is the response coming back. It wasn't half as strong as we wanted.
It was very loud.
And all the EME guys in the room were going, "That's brilliant!" And we were saying, "No, not enough signal."
Yeah.
And that's where we were, unfortunately. And I think the main problem with our estimation was nobody recently had used a dish that big to illuminate the moon.
I've got a slide on that in a minute, so we'll
Okay.
come to that. So I think one thing Dave didn't say is that he also put in a receive video mute, because we were convinced that we could convince our eyes that we were convinced we'd seen a signal. So we specifically muted it when we were transmitting, so we only ever saw what could have been a received signal. Otherwise, you know, your eyes play, you know, oh, I'm sure there was some sync bars there. But no. Anyway, we did FM voice tests, and whilst it's quietening, it's very, very raspy. Yes, I can play this. Right. So this is actually voice tests from the second visit on 5.6 gigs. That's transmit.
Golf Bravo 6, Golf Hotel Yankee.
It's all right. Keep going.
Bravo 6, Golf Hotel Yankee.
You notice how it sounds quietening, but
Golf
when
Bravo 6, Golf Hotel Yankee FM.
it's very edgy, sounds off frequency.
Golf Bravo 6, Golf Hotel Yankee FM.
Yeah, so it was fully quietening. It looked loud, but you could hear that edginess. That's the phase distortion when you're bouncing off a non-coherent reflector, which is a long way away. So unfortunately, when the AM didn't work, we kind of said, okay, well, we tried. Nobody else had tried, so we tried.
Were you circularly polarised, mate?
It's circular, yeah. I can't remember which way, but
But it doesn't matter.
whatever.
Yeah,
What?
it comes back reverse, you see, don't it?
Yes, yeah, exactly, yes. But we had the EME experts there to worry about all of that. So, yeah. So we then organised an EME weekend, which was advertised within the EME community, and we worked 50 plus stations on 3.4 and 5.6. We were running 50 watts. The performance of the dish at 3.4 gigs was not great because, if you remember, I said it's a 3.7 gig feed. So we were actually seeing a return loss of 50 watts up. We saw 4 watts back, plus we saw 4 watts on the other polarization receive port. So we know where 8 of our watts were going, and it wasn't up there. And it comes down to, you know, the loss in the tunnel and the feed being off frequency. But even so, they they worked a significant amount. And these were our moon bounce echoes on, I think again this was 5.6. That's loud. And in moon bounce terms, I mean that is,
Absolutely.
yeah.
Won't ask what your ERP was then, though.
Well, you can work it out yourself. 56 dB gain, I think it was 56 dB gain. I mean, how much we were getting up there, we're not sure, but even if it was only 25 watts, that's still,
It's a lot. Mega.
yeah, in mega. Yeah.
It's in mega.
I would be interested.
Sorry?
What the ERP was.
Um,
You've got a maximum.
no, we haven't got a maximum ERP. We've got 400 watts into the aerial. We did not exceed that, and that's one of the reasons why Goonhilly wanted us to do it, because they couldn't do it. They're not licensed to. They couldn't get a license to do what we were doing. Your license says 400 watts into the aerial. Do you want to talk about this, Dave?
Just briefly, the reason we weren't sure what we would get out of on the echoes were most guys over illuminate their signal. A lot of it goes past the moon, and then a little bit hits the moon and gets bounced back. So the bigger dish they get, the bigger the signal gets, because they're getting more of their signal onto the moon. But of course with our dish we were getting that much, illuminating that much of the moon. In fact, at early times we were not quite tracking the centre of the moon. We had some issues with,
That's right.
with not
Yeah.
tracking the parallel
I think we
surface.
thought we'd be about 25%
Yeah.
of the moon.
And we thought as you tighten that up, well maybe because it's more parallel you're going to get more signal. No, it didn't really work actually. Once you've illuminated the whole of the moon's surface, dish gain doesn't seem to make any difference.
The optimum is just to illuminate the moon.
Half
Yeah.
a degree beam width is your optimum.
Yeah,
Yeah.
yeah.
Doesn't it reduce the vibration effects? So
Because you're not seeing around the Earth, but you're not seeing so much of you're not seeing so much of the dish, the moon.
Working another station with a similar sized dish, you think they've both got two well-baked,
You could almost miss each other.
you both have to be pointing at the same point on the blade.
Absolutely. It's more difficult with a bigger
Yeah.
dish.
Yeah, yeah,
Lower left quadrant is the
yeah. We did manage some SSB contacts. I'll tell you a funny story after we've listened to this one. This is Peter G3LTF. It wasn't the best DX, but it was the one. It was probably the best SSB contact that I could find quickly this morning. So this is a sideband contact. He runs a 6-7 metre dish out of his garden near Andover. Ready, Ashley? Where's my mouse?
Anyway, we're talking about the inside there. Thanks for the Kyoto. Let's just try and work a few more. Thank you, Journey home. 73. Golf Bravo 6, Golf Henry, Yankee, Golf 3, Lima Tango, Fox, over.
Okay, so
GHY,
so that was G3LTF on sideband. We actually worked VK on sideband as well. That would have been on 5.6 as well, I think. Yeah, all of the best stuff was on 5.6 because of the mismatch of the feed on 3.4. So, I mean, we worked. So Brian had announced it on MoonNet, so everybody was set up for it. When the moon rose at about 11 o'clock in our east, we worked VKs in Melbourne and Sydney, and we got the world record for an SSB contact on 3.4 gigs to Australia. Then we worked Japan, and then it came through Russia, Europe, a lot of Europeans. And then towards the end of the day, east coast of the States, and we finished by working guys in San Diego as the moon rose with them. So we pretty much, you know, covered the lot. We also played around with the sun. Well, you would, wouldn't you? Now this, yeah, it's on 6 SEMS. We saw 20 dB of sun noise. The prediction was it should have been 23. There again, we don't know what state the feed was, so we may have been 3 dB down. But then we did the most interesting thing. Brian, G4NNS, was very keen to see if we could hear any of the stars, or, hang on, I'm not sure of the correct term. I need to be careful here because I've got an expert in the audience. But we took a listen for some bits of rock a long way away, in particular Taurus. Because we couldn't absolutely guarantee the tracking on the dish, what we did, we positioned the dish and waited for the Earth to take us so we could then hear it. And we actually heard Taurus A, and we heard 1.7 dB of noise coming off Taurus A. And that, how many light years away? 4,000 light. And that, I think that was on 3.4 gigs actually, which was pretty interesting. You know, I mean, that's DX if you want. I think it's 4,700 light years away. Yeah.
Are you waiting for the reply? Are you waiting for the reply?
What would you have done if a voice had said hello?
Right. Right. Make sure you watch. On the Saturday, we got TX Factor down. Bob McCready and TX Factor came in and did a piece. That will be good. It will be out later this month. Make sure you watch it. Absolutely hilarious. So we'd been having these contacts, and all of the contacts were pre-aligned on the HB9Q logger, which is basically a DX spot or whatever for EME. So on the chat window, all of them had been lined up. Bob McCready finished filming. He's got his own call sign. He said, "Can I have a go?" So, yeah, no problem. Yeah, have a go. Yes, you can use your own call sign. What do I say? You can say what you like. So he sat down. They got the film camera lined up. Everything was ready to go. Bob sat down there, used his own call sign, called CQ. They said, no, take that again. So he heard his echo come back. He called CQ again, heard his echo come back, and an SM7 came back. For a CQ call on the moon. I mean, he was blown away. We were blown away. We'd never had that happen. You know, it's just so funny. When TX Factor comes out, take a look at that. Really, really funny. So good. So what next? Well, you know, we've had some great fun down there, but Goonhilly are now saying, you know, you've had your fun. Now, you know, really we need to formalise it if anything further goes on. Basically, they're trying to become a business. They are a business, and so they're saying to the amateur radio community, there is an opportunity to become involved, to help preserve some of the technology history of this country. And there is an opportunity potentially to reopen the visitor centre and use it as the vehicle to generate funds to restore Arthur and to have access to Arthur. Now, this seems a bit off the wall for the amateur radio community, but if you think the steam railway preservation model, that's exactly the steam railway preservation model. All of your steam railways have a limited company whose job it is purely to run it, and they have a charitable trust which you belong to and you generate funds. So we're not saying the company would be Goonhilly, but it would be separate. You wouldn't be contributing to Goonhilly satellites, but there is an opportunity to become involved in running a piece of technology, historical technology, and having access to it. We're not sure what shape it's going to take or what form it is, but we're just sounding out to see what interest there may be. And it really could work because it's ideal, because those of you who've been to site may remember that this is the main perimeter, sorry, this is the perimeter of the main site. And Arthur, this is Arthur, this is the visitor centre, these are the visitor centre car parks. They're all outside the main perimeter fence of the site, but they're within their own perimeter fence. So it's a self-contained piece of real estate that could be put together and run as a project, a STEM outreach, playing with big dishes fun. So, you know, that's where it's going to go, or that's what they're saying to us at any rate. There are potentially plans to use Arthur for astronomy as well, but, you know, so we're not sure quite where it's going to go, but if we're trying to sound out what the interest is. So if this is something that kind of interests you and you think, yeah, that's something I'd quite like to be involved in, either as a fundraiser or a volunteer, you know, doing stuff, you know, let us know. Sorry? Yeah, I think it's a great opportunity. And I mean, it's not new. I mean, Germany, Dave and I went to Bochum, which is a 20-metre dish. They've done it there. That's run by there's a German word for it, a trusty technology institute. Yeah. And there's PI9 Cam, which is the dish at Duolingo in Holland. And they took it from, it was in far worse condition than this, and they basically took it over and restored it. And they raised over €1 million to do that. I personally believe that funding would not be a problem to do this. I think if you opened it, there'd be grants for STEM outreach, there's grant for Cornwall tourism, there's grants, English heritage, you've got industrial heritage grants. I don't think the finance would be the problem, but it's...
You say this one is listed?
Yeah,
Okay, so...
that's grade 2 listed.
Right, so the owners have got an obligation to maintain it.
Exactly. And they've also got the problem that GHY3 over here is also listed. So they've got their hands full. So it does limit what you can do with this, because you know what a listed building's like. You have to get permission before you paint it. But just to restore it back to its original condition. And it works on L-band. L-band equals 1300 megs, you know. So that's where we are. That's the fun we had. You know, yeah. Good. Any questions?
There's the other related institute, in fact, there's the other related matter in Sweden, of course, right at the other end of the spectrum, and that is the world's only electromechanical transmitter, which is operated on a symbol.
Yes, that's right. So, you know, the model is not new, you know, and the railway preservation guys do this all the time. You know, we could have gone there this time, but who's going to travel to Cornwall? That's its only disadvantage. Yeah, you would. It's a long way from nowhere, low way from anywhere. So, yeah.